In this video, I'm going to see if I can use a water simulation like this to flip a box. First, I'm going to need a water simulation, so I'm going to put down a geometry node, dive inside. There are some nodes that allow you to create a water tank or a water source, but essentially what you need are some particles or a volume. So I'm going to put down a box, and then I'm going to fill it with particles with the points from volume node. This node fills the box with points, so each point is 0.1 meter away from the neighboring point. So the distance from here to here is 0.1. Now I'm going to put down a null to reference inside of the simulation. I'm going to call this something like, let's say, into dots, and then I'm going to put down a dot network. Dive inside, and here we can create a flip object. This will keep our body of water, so you can see there is already something inside of it, but there is just some particles from this, so I'm gonna remove this path and it's empty. Now to get the particles from up here, these ones, I'm gonna choose input type as particle field, and then I'm gonna point this subpath to it, so I'm gonna go out of this node, then up one level, and then the null is called into dots. And we got our particles. Or you can do it through this guy here. So here we have a particle separation, and just make sure it matches whatever the point separation is up here. So again, this is just the distance between the particles in the simulation. So it's basically the resolution of your simulation. Now let's put down a flip solver. Let's hit play. Nothing happens. And that is because there are no forces acting upon the body of water. So let's put down a gravity node. Gravity force, and let's play the simulation again. And the water falls down. So if you see the purple box out here, that is the bounds of the simulation, or the bounding box. And that is set on the flip solver. Inside of the volume motion, you have the volume limits here. And it's this box. So right now it's 50 meters times 50 meters times 50 meters, which is really big. So I'm just going to decrease this to maybe 3 meters, 3 times 3 times 3. So we have something like this. Now if you play again, the water disappears out of the boundaries of the volume. So let's close the boundaries. So that is on the flip object. We have the option to close boundaries here. And now the water will stay inside the box and collide with the box. This node imports the points, and from the points it creates the fields needed to run the simulation. And you can see these fields in the geometry spreadsheet. We have geometry with all the points and their attributes in here. And then we have all the fields, and the one that we'll be paying the most attention to is the surface field. And if you take a look at the properties, you can see this surface field has the division size of 0.2. And that is double the particle separation because the grid scale is set to 2. You can think of this as a 3-dimensional grid in the background that helps update the points and helps the fluid keep its volume. And if you want to take a look at it, you can go into guides and you have it here, surface. And if you hide the particles and show the surface and play the simulation, you can see the actual surface field. The particles helps with detail, but the surface helps with keeping the volume of the simulation. So the water does, for example, not collapse in on itself. So these two play together to create our simulation, but as we are tweaking the simulation, we'll mostly be looking at the particles. So now instead of importing the points, let's import a volume. So I'm gonna go up where the box is, and I'm gonna put down a VDB from polygons. And then for the voxel size, I want to match the resolution of the simulation. And again, that is the particle separation times the grid scale, so it's 0.2. So I'm going to set this to 0.2. And then I'm going to connect this into dops. And we can also say fill interior. Now inside of here, if we go to the first frame, there is nothing really in here. So in initial data, I'm going to change the particle field to a surface up. And now it brings in the surface volume, this one. You can see it here. And creates the points according to that volume. So if we play again, it doesn't look much different. This flip object is created on the first frame of the simulation. So this is the creation frame that is connected to the start frame of the simulation. And it also gets its name here. So it's set to take the name of the node. And you can see in the geometry spreadsheet it's called flip object 1. But what if we wanted to keep emitting the water? Then we have to do something different, because this is created with the water inside on the first frame, but you can't really add to it. So I'm just going to remove this one. So now we have an empty water container or a flip object. And then on the right side over here, I'm going to feed it a source. So I'm going to put down a volume source. And I'm going to import both a volume here and some particles. So I'm going to have to go upstairs, and I'm just going to merge these two together. And then connect the merge to the null. And now if you middle mouse click, you can see you have a bunch of points. And then we have that one volume that's called surface. So back inside of the DOP network, we can connect this source to the last input of the flip solver. And then I'm going to point this path to the null. So I'm going to go out of this node, up one level, and then I'm going to grab the into DOPS null. And then I want to add one field, and it's a scalar field. It's a float, and the source volume is called surface. And the field I want to target is also called surface. It's in here, this one. And then I want to add it, so that's fine. Then on the particle side, I want to search particles as well. And here is asking for a group, and none of my particles have a group. If you go here, there's no group here. So you can either put down a group node, or this node also allows you to create an output group. And I'm just going to call it the same, particles. And now if I play the simulation, it keeps emitting, but something is going on with the visualization. So I'm just going to go into the flip object, and inside of guides, I'm going to go into particles. And instead of using sprites, I'm just going to use particles. And now we have a bunch of water coming down. I recommend toggling real time down here. And you can see how the box keeps emitting and the bounding box keeps filling up with water. Instead of setting all this yourself, you can choose to initial this node to source flip, and then it's going to set these parameters a little differently, but I think actually better. And now that we got the very basic weather simulation going, let's see if we can use it to flip a box. I'm first gonna increase the size of the water container. So now the bounding box is 3 meters, so let's take it to 5 times 5 times 5. So it's like this, and then I'm gonna move the box a little higher. So I'm gonna go upstairs and take this box a little up. Let's try 1 meter up, something like this. And let's play. Yeah, and then I'm gonna go upstairs and put down another box. So here on the side, I'm gonna put down a box. So this is gonna be our box that we're gonna try to flip. I'm gonna move it to the side, somewhere like here. And then I'm gonna pack it, since I'm going to be importing it as a packed rigid body object. So I'm gonna put down a pack node. And you can see now we have a packed geometry 1.1 primitive. And then I'm going to put down a null to reference inside the simulation. And I'm just going to call this RBD for rigid body dynamics. Back inside the simulation, I'm going to put down a RBD packed object. I'm going to point the subpath to the nulls. So it's out of this node, off one level, and then I just called it RBD. So it's this null here. And we got it. You can change the density of the box. So now it's 1000 kilogram per square meter, which is the same as the density of water. And theoretically, for things to float in water, their density need to be lower than the density of water. So I'm just going to take it to something low. Let's start with 10. So it's a very light box. Then I'm going to put down a bullet solver. Bullet solver. Connect it. And I'm going to merge these two together. And move the orange flag. Now you can see you have water and the box, and if you play it, you have both. And also in the geometry spreadsheet, you can see you now have a flip object and you also have a RBD packed object. Again, the object takes the name of the node and its creation frame is the first frame, but I want a little bit of pre-roll of water before dropping the box, so I'm going to change the creation frame. So I'm going to delete this channel and change this to 50. So I'm going to give it 50 frames to gather a little bit of water before our box hits. And let's see how it goes. Yeah, something is happening. Something is happening, and we managed to flip the box. So congratulations. And you can also see how the RBD object appears in the geometry spreadsheet on frame 50. So here it comes in. And off it goes. Down into nothingness. I'm going to write the simulation out to this. So down here I'm going to put down top import fields. I'm going to point it to the dot network. So I'm just going to drag and drop the dot net into this parameter. And then it wants to know which node. And the node it wants is the flip object node, which is this one. So I'm just going to go out of this node into .NET, this one, and then the node is called flip object. Then I want to import three things. The object is flip object 1, like you can see in the geometry spreadsheet, this one. And then I want the particles, so that would be the geometry. We're already seeing them because the field is empty, then it takes it by default, but I'm gonna put it anyway. Then I want the surface volume, which is this one. So the same object, flip object 1, and the volume is called surface. And then I want the velocity as well. So flip object 1 and the velocity field. So this field here. Well, I'm just going to make the fields invisible. So I'm going to set the visualization to invisible. But if you want to see the fields, you can. For example, if you'd like to see the surface, you can first isolate the field with a plus node. And I'm going to just choose that one field, surface, delete non-selected. You can see in the primitive section of the geometry spreadsheet, we have one primitive called surface. Then we can, for example, use a primitive properties node to visualize it. So plug this one in. And inside the volumes, you can say adjust visualization. And for example, we can look at it as an isosurface. If you want to see the velocity field, you can visualize it with the trail. So I'm going to put down a plus node. And then I'm going to isolate the velocity field. And since the velocity is a direction, it's a vector, so x, y, z, I'm just going to pick up all of them. And then say delete non-selected. So now we only have the velocity fields. Then I'm just going to put down a scatter node just to get some points. And I'm going to put down a volume trail node. This will create trails from points based on volume. So these are going to be the points, and the velocity volume is the volume. So you can see in which direction the velocity fields are pushing the water. Now back to the simulation, you can use a fluid compress node to make it a little bit smaller on disk. You can see that you still have the surface and the velocity field, but it has packed the points. Then to pick up the box, I'm going to use a DOP import node. So in here, I'm going to put down a DOP import. And again, I want this DOP network. And then for the object, I'm just going to pick the RBD packed object. And you can see the boxes here. I'm just going to merge these two together and write them out to disk. So it's the first output of this node. And then I'm going to put down a ROP geometry output node. I'm going to call this something like simulation. I want to render the full frame range. And then I'm going to make an extra folder, copy this, that has the name of the scene file and this node, simulation. Save to disk. Then I'm going to bring it back into the scene. Put down a file. And it has created this geo folder. And in here is the simulation. I want to remove the box. If you look at the points in the geometry spreadsheet, you will see you have a name attribute. This one. And one of it has the name RBD object. And that is the name given to the object by this node. So before doing anything with the points, I'm going to remove the box. So I'm going to put down a blast. And I know it's a point attribute, so I'm going to change the group type to points. And then I'm going to set if attribute name is equal to RBD. I don't remember RBD object something, but I know it's RBD something, so I'm just going to put a star. So we don't have any box anymore. Nothing with the name attribute RBD. And now to turn these volumes and particles that have been packed into a geometry mesh or a water surface, I'm going to use a particle fluid surface. Connected. The particle separation is already set to 0.1, just like our simulation. Then I want to use a bounding box to cut away some parts of the simulation. And I'm just going to set it to the same as the bounding box of the flip solver, which is 5 times 5 times 5. And then I'm just going to close the boundaries. If you middle mouse click or check the info card of this node, notice the volumes are gone and you just have this one polygon soup. You do have a name attribute here, and if you take a look at it in the geometry spreadsheet, it's on the polygon soup, but it's not the surface volume that we had before. It's just an attribute on the geometry. Then I want to get the box as well, so I'm going to go back here, put down blast. And again, I'm going to use the name attribute, and it's a point attribute. So I'm going to say if name is equal to RBD something, delete non-selected, and then we have the box. I'm going to merge the two together. Find the place for the camera. And then new camera. Guess I can adjust it a little bit. And unlock. And then I'm going to make a flipbook. I'm going to right click and choose new settings. And in size, I'm just going to untoggle these two and start. And now I want to start increasing the resolution. So I'm going to save the scene and then I'm going to version up. version 2. And then I'm going to go up here. And first with the points from volume, I'm going to decrease the particle separation. So instead of having 10 centimeters between particles, I'm going to take it to 0.003 meters, which is 3 centimeters. So I have a lot more particles. And for the VTP from polygons, I also want to take the voxel size down. And again, the voxel size should be double the particle separation. So I'm setting the particle separation to 0.03, so this should be 0.06. So now you updated this, then I'm going to go into the simulation. I'm going to take the particle separation to 0.03, and we don't have to change the grid scale, we still want it to be double. Then up here, I'm bringing in the points and the volumes and I'm compressing them. So in here, I also want to match the particle separation to what we had before. So that would be 0.03, that is 3 centimeters, and we can write it out again. I'm going to take the timeline down to 200 and save to disk. That took around 15 minutes and I have the files in here. You can see that on the later frames, the size is around 6 megabytes per frame, so the whole thing is a bit more than a gigabyte. I'm going to update this file node. So simulation 2 has left. So I have everything inside of here. And if you look at the info card, you can see that the surface and the volumes have the voxel size of 0.06. Now let's see how this looks. I'm going to take the particle separation down to 0.03 when we make the fluid mesh. You can see it's a bit higher resolution, and I'm just going to write this out to disk real quick. I want to write the full frame range. I'm going to create another folder and I'm going to change the name of this node and then save to disk. This took around 6 minutes and we got the new folder in the geo folder and all the files in here. I'm just going to flipbook it real quick, so I'm going to put down a file now to read it back in. Now we have it in here, and then I want to merge it with the box from the simulation, this one. And flipbook. So right now the whole simulation is around 1.14 gigabytes. So I got some room to increase the resolution. But first I'm going to version up the scene. Version 3. And then I want to give the box up here a little bit of life. So I'm going to go up here to the box before I do anything to it. And I want to remesh it. And I think I want the target size, so the size of these triangles, to be around 0.05. And then I'm going to give this a mountain. So basically add the noise value to the P attribute. I'm just going to take the roughness to 0 so I can find a good element size. So right now it's 1 meter. Maybe we can take it down to something like this, 60 centimeters. I also want the amplitude to go down. And then I want to bring a little bit of roughness back and I want to animate the noise pattern. So if we play this, I think I wanted to go a little faster, so I'm going to take the pulse down. And just to make sure I'm seeing it real time, I'm going to make a quick flipbook. I think it's good. Then I'm going to connect this into everything, so we'll get a little bit more shape to our stream down here. So for the resolution, I think I'm going to have this value, so 0.015 or 1.5 centimeters between points. Then I want to update the VTP from polygons. This will be 2 times 0.015, which is 0.03. Then I'm going to go to the first frame and go into the simulation. And I'm going to change this to 0.015 as well. And then finally, in the fluid compressed node, I want to take that down as well. So 0.015. This is going to take some time to simulate, so I'm just going to save the scene. And then in the wrap node, I'm going to save it to disk in background. This will run the simulation as a background process and allow me to keep working in the scene. And to see the progress, we can open up the render scheduler. So the first frames are faster because there is less water there. And you can see the files in here. And they're up to 25 megabits per frame. And they're probably going to keep getting a little bit bigger. Make sure there is enough space on your computer. If it's taking too long or taking too much space, stop the simulation and increase the parameters we changed. So that would be the points from volume here. And then you would want to make the VTB double that. And then you also would want to take the particle separation of the flip object up and the particle separation of the fluid compress node. So regarding what value is good to use for the particle separation, you should think about the full scale of what you are simulating. So if you are doing something very small, like a small splash, smaller than this one, you would need a lower value, maybe less than a millimeter between points. But that's okay, because the simulation domain is smaller, so it wouldn't get too heavy. If you were simulating something very big, like a large waterfall, you can get away with a higher value, maybe some centimeters between particles, since the camera would be very far away from individual particles. Let's take a look at what we got. So in the file node down here, I'm going to replace this one with the new one, version 3. And right now all we see is boxes. So I'm going to use another particle fluid surface node to see the particles. And in here, I'm going to say convert to particles. I don't want to be calculating the surface since we have the simulation going in the background. And now to get some color, we can use the length of the velocity or the speed to give us a better clue of what is going on in the simulation. So I'm going to put down an attribute WAP. I'm going to move the blue flag. In here, I want the velocity, and I want to take the length of the velocity. Then I want to fit this value. And I want to say if the velocity used to be 0, keep it as 0. But if the velocity coming in was 10, make it 1. 0 to 10 goes to 0 to 1. And that allows you to feed it into a ramp parameter. And then we can keep it as a color ramp and feed this into color. Then upstairs, I'm going to use one of the presets for the colors, and I'm just going to go with the whitewater one. So now you can see a little bit better what's going on in the simulation. If you want, you can also change the particle visualization in the display option if you press D with the mouse above the scene view. And then in geometry, you can change display particles as pixels. Yeah. The simulation took a bit more than an hour. Each frame was up to 32 megabytes and the full frame range around 5 gigabytes. Let's see how the water surface looks. So in here, I'm going to change the particle separation to 0.015 and move the blue flag. This takes a bit of time as well, so I'm going to write the water surface to disk. You might want to start with some small portion in the middle, maybe 50 to 100 first, but I'm just going to write all of it. And it's finished, so I'm going to read it back in here. So surface, water surface 3. And if you take a look at the attributes, you can see the surface has a velocity attribute, which is good because we can't use a trail node to calculate the velocity on this, since the point order and point count is constantly changing on every frame. Then I'm also going to write the box out to disk, so I don't have to load the full water simulation every time I want to read the box. So I'm going to put down another rough geometry output. I'm just going to call this box. I want the full sequence. and then I'm going to add another folder. So copy this and then slash and paste. Save the disk. And I'm going to bring it back in. And this 3 box. Before I set up the render, I just want to make one more flipbook. Yeah, something like this. I'm going to make output nulls for both of these. So for the water, I'm just going to call it render water. And the box is actually packed, so I'm going to unpack it. Then it doesn't exist before frame 50, so I'm going to clamp its frame range with a time shift. And I'm going to say clamp to first. And in here, instead of having this expression, I'm just going to write 50. So now it just stays still up here until it starts falling. I don't have a velocity vector, so I'm going to calculate the velocity with a trail node. And I'm going to choose compute velocity. So now we do have some velocities and make a null for it as well. And this I'm going to call render box. I'm going to make 2 new objects up here where I'm going to render, so geometry. So this one is going to be render water. Inside I'm going to put down an object merge. I'm going to pick up the render water null from geo1, so I'm going to go out of this node, off 1 level, into geo1, and then the null I want is called render water. And then I'm going to put down another geometry object. This one is going to be render box. I'm going to go inside, put down an object merge. Again, I'm going to go out of this node, up 1 level, into geo1, and then I want the render box. Then I'm going to save the scene and go into Solaris. I'm going to import the objects and the cameras, so I'm going to put down a scene import node. And in force objects, I'm going to choose the camera, the render water, and the render box. I'm going to hide the grid, look through the camera, and I want to see the renders, so I'm going to choose the Karma CPU. And then I want some motion blur, so I'm going to put down render geometry settings. And you can see in the geometry spreadsheet, you have render box and render water. And these are the objects I want to apply the motion blur to. So in primitives, I'm just going to write slash render water and space and slash again render box. And in motion blur, I'm going to select to set or create velocity blur and velocity blur. Now if you move the blue flag, you can see a little bit of blur from the velocities. I want to give these 2 objects some material, so I'm going to put down a material library. I'm going to dive inside and I'm going to open up the material palette. And what I want is a principled shader for the box. And then I'm just going to take a basic liquid shader for the water. I haven't assigned them yet, so nothing's going to happen, but I want to change the base color of the water to white. And I'm just going to change the base color of the box also to white. And I'm going to go upstairs and put down an assign material node. Move the blue flag. I want to assign 2 materials to 2 objects, so I'm going to increase this. And then one of the objects I want is the render water, and I'm going to pick up the materials from the material library, so that's the basic liquid one. And the other one is the box, so the object is a render box, and the material also in the material library is the principled shader. Then I want to add some lights, so I'm going to put down a dome light. And it's enough just to merge this with a tree or You can actually also put it in the tree, but I'm just going to do it like this. So you can see now you have some lights, and inside of lights there is the dome light. Move the blue flag. You can see we have a lot of lights. I want to use an environment map or a texture. So in here I'm just going to go to the textures that come with Houdini. In here, the HDRIs, I'm just going to choose the garage SF. I think it's too bright, so I'm going to take its intensity a little down. Let's say 0.5. And we can rotate it something like this. I'm going to hide the light geometry in the scene view. And then I'm just going to hide the picture in the background. So I'm going to press D to open the display options. And inside the background, I'm going to uncheck display environment lights as background and just set the color scheme to dark gray. Then I'm going to put down an area light as well. I'm going to connect this to the merge as well, and you can see that it becomes a bit brighter. And I'm going to move it a bit back and increase the exposure. Let's just try something high. Bring it a bit further back. And then I'm just going to go and look through the light. So instead of the cam, I'm going to go to look through light and choose the area light. Then I'm going to lock the light to the scene view, and then I can move it around a little bit. So how about if we just look through the water from below? Or wherever you feel like it's good. I'm going to unlock the light from the scene view and then look through the camera again. Then I'm going to put down a karma setup. This is going to give us the 2 nodes. I'm going to choose my camera. For the output file, I am going to create a folder for it inside of the render folder. So I'm copy pasting the name of the file and the name of the node. And then inside of camera effects, I want to turn off the depth of field and then name this node something like flip. So the render files are going to be named flip. How to flip version 3.flip. I'm just going to render out the full frame range. And then I'm going to save the scene and render to disk in background. And let's check the render scheduler. The render has started, and this is the first frame. So it loops through every frame like that. And on disk, you can see we have a new folder render, and inside of here, we have the first frame out and now the second frame. And it's currently rendering the third frame. So this is going to render the full frame range, and it's going to take forever. So probably you might want to go and reduce some of the render settings so each frame is quicker. And put the start frame to somewhere in the middle, so maybe render frame 60 to something. And the render has finished, so let's take a look at it. So that's it. In the next video, I'm going to talk a little bit about things colliding with water. Hopefully see you there, and thank you for watching.